Hey everyone, welcome back to Drill Coding. This is part 5 of our top 10 Java interview series. Today we are covering some real developer level topics like reflection, atomic integer, thread local and more. If you are preparing for interviews or want to level up your core Java concept, then this one's for you. Let's start with one of the most powerful tools in Java, the reflection API. Reflection allows us to inspect and manipulate classes, methods, fields and constructors at the runtime, even when we don't know them at compile time. This is very useful in frameworks like Spring, Hibernate, and tools like JUnit where code has to behave dynamically based on annotations or configuration. Let's understand it with simple example. So this line imports the method class from the java.lang.reflect package, and here we created a simple student class with a study method, and this is our second class which contains main method here. Class.forename dynamically loads the student class into memory at runtime. Here this creates a new instance of the student class using its default constructor, and here we fetch the method name study from the student class, and finally we invoke the study method on the created object, so output will be studying. And why is this important? This is exactly how a framework like Spring works behind the scenes. They create object dynamically, inject dependencies and call methods without writing manual logic. So in interviews, if you are asked about dynamic behavior, annotations or Spring internals, reflection is the hero behind all that magic. Let's see next question. Second question is, what is atomic integer? In multi-threaded programs, we often need to update a variable, but if multiple threads try to increment it at the same time, we get race conditions and the result becomes unpredictable. So atomic integer solves this by allowing thread safe operations without needing to write synchronized blocks or logs manually. It comes from the java.util.concurrent.atomic package and internally uses compare and swap operations to ensure atomicity. Let's see how it works with a simple example. Here we declare a shared counter using atomic integer initialized with 0. Then we define a runnable task that increment the count 1000 times using increment and get method. So instead of count plus plus, we are using increment and get method here. Then we created two thread here, T1 and T2, to run the same task. We start both threads here, and here join ensures both threads finish before we print the final count. And finally we print the result. The count will always be 2000 because of atomic integer. If we had used a normal int with count plus plus, we might have seen inconsistent results like 1500 or 1700 due to race conditions. But here, because of atomic integer, the result will always be 2000, which is guaranteed and thread safe. So we use atomic integer in thread safe counters or ID generators, and inside concurrent collections and performance sensitive code, and also in logging libraries where multiple threads need consistent tracking. This is all about atomic integer. Third question is, what is enum in Java? Enum is a special data type that defines a fixed set of constants. It's way better than using plain final static variables because enum are type safe. It can have fields and methods and prevent invalid values from being passed. You should use enum when you know the values are constant and limited, like days of the week, levels of access or application states. Let's see example. This defines an enum called level with three constants, low, medium and high. Here we assign the value medium to the level variable, and then we use switch expression here. We use switch expression here to check the value of level and print appropriate message. Why do we use enums instead of strings or integers? It's because of its type safety. Compiler prevents invalid values and its readability, and because of its functionality, you can even add methods, fields and constructors in enums if needed. In Spring Boot, you often see enums in REST APIs like setting status.active or status.inactive. Also in logging levels or configuration states. Enums keep your code clean, safe and meaningful. Moving forward to the next question. Difference between array and array list. Both array and array list are used to store elements in Java, but they are very different in how they behave and when to use them. An array is a fixed size structure. Its size can't be changed. It can store both primitive types and objects. On the other hand, array list is a part of Java collections framework. It's dynamic. which means it grows or shrinks automatically, but it can only store objects. Let's quickly see an example of both. Here A1 is a simple array with fixed size 3. You can store int values directly here, and list is an array list here. You can keep adding elements because its size adjusts automatically. So key differences here is array is fixed in size and array list is dynamic in size. Array can hold primitives and array list only holds object. And on the basis of performance, array is slightly faster than array list, and there is fewer built-in methods in array, and array list have many helpful methods like add and remove. So use array when you know the size in advance and need performance, and use array list when you need flexible growable list and want built-in utility methods like add, remove, contains. Next question is, what is Java memory model? Java memory model or JMM defines how threads interact with memory. More specifically, how changes to variables by one thread become visible to others. Without JMM, every thread might cache its own copy of a variable, which could lead to stale data being read even if another thread updated the original. The JMM sets the rules for visibility, ordering, and atomicity, all critical for writing safe multi-threaded code. Here's a basic example. Here the volatile keyword tells the JVM that hey, don't cache this variable, always read its latest value from main memory. So if thread A changes flag to false, then thread B will immediately see that change. So there is no delay. Then thread B will immediately see that change. So without JMM rules, thread could work with stale or inconsistent data. Sixth question is, what is ClassLoader in Java? In Java, every .class file, whether it's your code or part of a library, is loaded into memory by a special component called the ClassLoader. And it's the first step before your Java program even runs a single line, because the JVM doesn't know about your classes until they are loaded, and Java uses a delegation hierarchy to load classes. Let's look this code example. Here this line returns the class loader that loaded your current class. Most of your application classes are loaded by the application class loader, and here this output statement usually prints something like this. And here bootstrap class loader loads core Java classes like java.lang, and extension class loader loads class from the ext directory, and application class loader load your project classes and libraries from. And each loader tries to delegate loading to its parent first, and this is called parent delegation model. It ensures that core classes are not accidentally overridden, and frameworks like Spring and Hibernate often use custom class loader to load classes dynamically. And in web applications like Tomcat, each app runs with its own class loader to avoid conflict. It's all about class loader. Let's see next question. Seventh question is, what are soft, weak, and phantom references in Java? So in Java, memory management is automatic because of garbage collection, but sometimes you need more control over how and when your objects are collected. That's where reference types comes in. Besides the regular strong reference which you are used to, Java provides soft reference, weak reference, and phantom reference in the java.lang.ref package. Let's understand all three types. Soft reference cleared only when memory is low and used in caching like image loading. So if memory is available, it stays. And weak reference cleared on the next GC cycle even if memory is fine. Weak reference good for maps like weak hash map where you don't want to prevent garbage collection. And phantom reference is most advanced, cleared after object is finalized but before memory is reclaimed, and it is used in low level libraries like memory pools or resource cleanup monitoring, and it requires a reference queue. And if interviewer asks when would you use this, then you can say use soft reference for memory sensitive caching, and use weak reference when you want automatic cleanup like in custom maps, and use phantom reference only in advanced tools like memory managers. Next question is, what is a daemon thread in Java? So in Java, threads can be of two types, user threads and daemon threads. A daemon thread is a low priority background thread that runs behind the scenes like a helper. The JVM won't wait for daemon threads to finish. It exits as soon as all user threads are done. Let's take an example. Here we created a thread with a while loop, an infinite background task. Then we call setDaemon before start, marking it as a daemon thread. Once the main method ends, JVM exits and it doesn't care that the daemon thread is still running. And if you forget to call setDaemon before start, it throws an exception. And where are daemon threads used? So garbage collector runs as a daemon thread, and background tasks like monitoring, logging and cleanup and thread pools may internally create daemon threads for idle management. So if you are asked will JVM wait for daemon threads, then you can say no. As soon as all user threads finish, JVM shutdowns and daemon threads are silently killed. That's all about daemon thread. What is the difference between runnable and callable? In Java, both runnable and callable are used to define tasks for threads, but there's a key difference. Runnable doesn't return anything and cannot throw checked exceptions. On the other hand, callable returns a result and can throw checked exceptions. Think of it like this: if your thread just performs work, then use runnable, and if it performs work and returns a result, then go for callable. Let's see example. We define a callable string that returns a string, and we use execute service to submit the task, and it returns a future which acts like a placeholder for the result, and result.get blocks until the result is available. And if we had used runnable, there would be no return value and we have to manually store output somewhere shared. In real world use case, use callable when doing parallel computation like downloading files or calculating scores, and use runnable for fire and forget tasks like sending emails or background logging. And if they ask which one would you use in multi-threading, then confidently say use callable when you need to get a result back from the thread. That's all about runnable and callable. Last question is, what is ThreadLocal in Java? In multi-threaded applications, we often face a challenge: how to give each thread its own copy of variable so they don't interfere with each other. That's exactly what ThreadLocal solves. It allows you to create thread-specific variables so each thread gets its own isolated value even though they are using the same variable. Here's a simple example. So here this sets up a ThreadLocal variable with initial value 0. Here each thread sets its own random value and read it independently. Now we start two threads. Each gets its own version of thread ID. No interface, no synchronization needed. And because sharing the same variable across threads can lead to race conditions, ThreadLocal provides isolation without synchronization. Real world use case here is user authentication to store current user ID or session per thread, and database connections to store per thread JDBC connections in web apps, and also logging. So framework like Spring and Hibernate internally use ThreadLocal for context management like transactions, security and request tracing. And if interviewer asks how would you handle data per thread without synchronization, then your answer should be, I would use ThreadLocal to give each thread its own copy of variable and avoiding shared access altogether. That's it for today's session. I hope these advanced Java questions gave you more clarity and confidence for your next interview. If you found this helpful, make sure to like, share and subscribe to DrillCoding. See you in the next video and all the best for your interviews.